Hi guys, today we're going to do section 8.5. Basically, we're going to take all of the things that we've learned about sine, cosine, and tangent, and we're going to apply it to word problems. So there's just two new vocabulary words today, or phrases. The first one is angle of elevation. And basically, the angle of elevation is the angle that's formed when you're looking up at something. So let's go ahead and draw a little picture here. So go ahead and draw yourself. Maybe here you are, right? And maybe you see an eagle flying. Here's the eagle, the one that lives over by Meadowview in the tree there along Flagstaff. Maybe you see that eagle. Well, the angle formed between your line of sight, so your horizontal line of sight, and the ray that would lead up to the bird, if you looked up at the bird, this angle right in here between your horizontal line of sight and the ray up to the object, that angle is called the angle of elevation. That is the angle of elevation. I'll read the definition. It says, the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer's eye, or the line of sight. So it's basically from your horizontal up to the thing that you're looking at. On the other hand, our second vocab word today is called angle of depression. So everybody, let's go ahead and draw Mount Everest. So here's Mount Everest. There's some snow up there, blah, blah. You've climbed it. You have reached the summit. Woohoo! Yes, celebration. There you are at the top of Mount Everest. But down below, you see your base camp, which is where you need to get back to so that you can sleep tonight. If you take a ray coming out at a horizontal and then another ray down to the object you're looking at, that angle in between those two rays is called the angle of depression. And so this would be the angle of depression. It's basically the angle formed when you're looking down at something. I'll read the definition. It says, if the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called the angle of depression. Now, the most common mistake that people make on the test for Chapter 8 is instead of putting the angle of depression between the horizontal and the line down to the object, they put the angle of depression right here. That is wrong. It is not down there between you and the ground. It is between your line of sight and the sight line down to the object. So you have to be careful of where you put the angle of depression. Okay, let's apply this to some word problems. A tree casts a shadow 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. Find the height of the tree. All right, first, draw your best tree. There it is. The tree casts a shadow that is 25 feet long. Go ahead and draw in the shadow. Our shadow will be on the ground here. It is 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree. So here's the tip of the shadow. Here's the top of the tree. The angle of elevation right in here is 64 degrees. Find the height of the tree. So what we're looking for is that right there. This would be a right angle. I can call this height of the tree X or H, and I'm going to solve for that. I'm going to use my trigonometry. So go from the angle that you're working with. In this case, it's 64 degrees. One of the numbers I see is 25. What side is the 25? Is it opposite of 64, adjacent to 64, or hypotenuse? It is the adjacent side. The other side that we're working with, that we're trying to find the height of the tree, that is opposite of our 64-degree angle. Remember, never use the 90. Now, think about SOHCAHTOA. You're going to pick the one that has the O and the A. O and A goes with TOA. T stands for tangent. Tangent of 64 degrees equals opposite over adjacent, so x over 25. You know how to solve this. Multiply by whatever's in the denominator. In this case, we're going to multiply by 25. And it's a matter of typing it into our calculator. 25 tangent 64 equals, and you should get 51.26 feet. Remember, if you're not getting this and you feel like you're typing it in the correct way, maybe your calculator is in the wrong mode. Make sure your calculator is in degrees because our angle is 64 degrees. Hey, by the way, this is something that somebody in real life could use. Let's say you're the forest ranger in the Muirwood Forest in San Francisco or near San Francisco, and your job each year is to record the height of the redwood at the end of the season and see how much it grows from year to year. You could actually use this system. You could get out your handy dandy clinometer. A clinometer is something that would measure this angle down here. You could measure from the ground up to the top of the tree. You could also get out your handy dandy tape measure and measure how far back you are from the tree. So you could get this measurement down here, you could get this angle right here, and then use your SOHCAHTOA to find the height of the tree. You wouldn't have to climb it that way. All right, number 2. A jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? Let's draw this. So a jet takes off. There it is, taking off. Let's draw our best airplane. There it is, fancy dancy airplane. It takes off at an angle of 19 degrees. So this angle right here that it took off at would be the angle of elevation, and it is 19 degrees. It continues to rise until it hits an elevation of 28,000 feet. That means it will be 28,000 feet off the ground when it decides to flatten its route and plateau, and that was probably going to be its cruising altitude until it starts its descent. So it's 28,000 feet above the ground. And we want to know how much ground distance was covered. All right, so again, we can use SOHCAHTOA. Think about your angle. Here's the angle that we're working with, and the 28,000 looks to be opposite of that angle. The x, the ground distance that we're trying to find, is the adjacent side. It's not the hypotenuse, so it must be adjacent. Think about SOHCAHTOA. Which one has the O and the A? If you're thinking TOA, you're right. So we're going to use tangent of 19 equals opposite over adjacent. Multiply by whatever's on the bottom. In this case, we're going to have to multiply by x. They cancel. To get rid of this tangent 19, to get x by itself, it's x times tangent 19. To undo it times, we're going to have to divide. For some of you, you might have been a little confused thinking you had to do inverse. You only are doing inverse when you're trying to solve for an angle measure. We're not solving for an angle measure, we're solving for a side length. Okay, so x turns out to be 28,000 divided by tangent 19. Type that into your calculator. And when I did that, I got 81,300, and it might be 317 point something on my sheet. I have about 81,318 feet. Now, if you look closely at the question, it wants to know how many miles were covered. What's the ground distance in miles? So how do we convert feet to miles? Well, there are 5,280 feet in 1 mile. So we can take 81,318 and divide by 5,280 feet and see how many times that goes in there. It turns out to be approximately 15.4 miles. And that would be the ground distance covered by the plane before it reaches its cruising altitude of 28,000 feet. Some of you might know of that business in Farmington where it's over by Schmidt-Mackey Arena, and it's an air traffic control center. There are people who work there who do this type of calculating all day long. Hundreds of times a day, they're doing trigonometry to tell a plane how much ground distance was covered, or figure out what angle they should take off at in order to reach their cruising altitude, or what angle they should start their descent at, how far into their trip they should start their descent at, things like that. And so if you're thinking about being an air traffic control person, you will use a lot of trigonometry. Number 3, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? All right, so we need a cliff. So here's our cliff. Okay, there it is. And if you're like me, like if I'm a little scared to go out on the edge of a cliff and look out, so I would probably be doing this. Like, okay, I'll peek over the edge, but I'm not gonna get too close. We see an object. Who knows what it is? Like, maybe it's a moose. Ooh, that'd be cool. So here's our moose. We see some kind of object down there. From the top of a 40-meter high cliff, so the height is 40 meters. The angle of depression with the object is 34 degrees. From our line of sight, the horizontal, down to the object, this angle is your angle of depression. Again, a lot of people think it goes here. It does not. That would be wrong. A lot of people put it there and get it wrong on the test. The angle of depression goes from the line of sight down to the object. We want to know how far is the object from the base of the cliff. So we want to know this distance right here, this. What I usually do you remember alternate interior angles? This and this are parallel. Right here and right here are parallel. This is the transversal cutting through, and that means this angle, 34, and this angle, they will be congruent to each other if the lines are parallel, and because they're alternate interior angles. Oh yeah, that geometry A thing. So that's what I usually do. I usually take that angle of depression and flop it down to the triangle below and use this triangle down here then. I'll outline it here in blue. I'm going to work with this triangle down here, and I'm going to try to find X. How far is the moose, or whatever that object is, from the base of the cliff? I'm going to find this side. So start with your angle. We're working with a 34-degree angle. This X, this ground distance, is the adjacent side to that angle. The 40 is the opposite side. Think about O and A. Think about SOHCAHTOA. SOHCAHTOA. Which one would you choose? I would choose tangent. So tangent of 34 equals opposite over adjacent. Whatever's on the bottom, you're going to multiply by that. So we're going to multiply by X. And then we're going to have to divide by tangent 34. Whatever we do to one side, we do to the other. So we really have 40 divided by tangent 34. We type that into our calculator, and X turns out to be approximately 59.3, and it's meters. That's how far that object is from the base of the cliff. The pilot sights the beginning of a runway and must approach it at a 5-degree angle of depression if the plane is 182 kilometers from the beginning of the runway, ground distance. What is the plane's altitude or height in the air? Round to the nearest kilometer. Okay, draw another airplane. Beautiful. Here's the runway. There's the runway that it has to land on. All right, so it has to have a 5-degree angle of depression. This is not going to be drawn to scale, but that's okay. From the pilot's line of sight down to the beginning of the runway is 5 degrees. Definitely not drawn to scale. If the plane is 182 kilometers from the beginning of the runway ground distance. Now this is the tricky part. From here to here is the 182 kilometers. So what I usually do is drop down a vertical line there so you can kind of see, like, directly below the plane from this spot to this spot where the runway starts, it is 182 kilometers, and we want to find out what is the plane's altitude right there. How high off the ground is that plane? Again, I like to use alternate interior angles. If this is 5 degrees up there, this is also 5 degrees down here. These two are alternate interior between these two horizontal lines and that transversal. So we're going to use this bottom triangle here, and we're going to solve for x. This side is opposite of the 5 degrees. That's the side we're trying to find. This side is adjacent. Opposite and adjacent go with tangent. Tangent 5 degrees equals x over 182. Opposite over adjacent. Multiply by whatever's in the denominator. Multiply by 182. And type it in your calculator. 182 times tangent 5. X should turn out to be approximately 15.92 kilometers. It says round to the nearest kilometer, so that'd be about 16 kilometers for the height or the altitude of the airplane. A surveyor is 100 meters from a bridge. The angle of elevation to the top of the bridge is 35 degrees. The surveyor's instrument is 1.45 meters above the ground. Find the height of the bridge to the nearest tenth. You might see these people along the side of the road when there's road construction going on. They have a little tripod. They're wearing bright orange vest, and they're doing some trigonometry, calculating the slope of the road or the road that they're going to build, perhaps a sidewalk. Okay, so our surveyor is 100 meters from a bridge. Here's the surveyor. Here's their little tripod, camera-y thing. There they are. And then here's the bridge. I'll just make it a fancy bridge. Maybe it's going over a river or something, right? So the angle of elevation to the top of the bridge is 35 degrees, but the surveyor's instrument is 1.45 meters above the ground. So this is a little tricky. From the lens here to the top of the bridge, that's the angle of elevation. From the horizontal line of sight to the top of the bridge is 35 degrees. Now this height right here is 1.45 meters above the ground. And we want to find, and also the surveyor is 100 meters from the bridge. So this distance from here to here, this is 100 meters. And we want to figure out the height of the bridge. So what we're going to do is we're going to find this height right here. And so I'll call it x. All right, you can see your triangle there. Figure out what two sides you're working with. If 35 is your angle, the 100 is adjacent. The side you're looking for is opposite. Opposite and adjacent go with tangent. You'll find you use tangent a lot in these problems. So it's tangent of 35, always the angle next, equals opposite over adjacent. Multiply both sides by 100. And then type it in your calculator, and it turns out that you get about 70.02. Go ahead and actually type it in. Pause the video if you need to. Make sure you're getting these answers. But that is not the total height of the bridge because we are only taking into account this. It is also off the ground 1.45 meters, same as the camera. This and will have to be added on. So we're going to add on 1.45 meters to get our total height, which would then be 71.47 meters would be the height of the bridge. That's a tall bridge. Finally, our last question. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person is in need of help. If the angle of depression to this person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person to the nearest foot? So you can see what we're looking for is this distance down here. There was an X there. That's the distance we're looking for. You can see the angle of depression was 42, but they used alternate interior angles. And so again, we're going to take a look here. We're going to see if our angle is 42 degrees right here. 18 is opposite, and X is adjacent. Once again, we're going to use opposite and adjacent. Go with TOA, which is tangent. Tangent of 42 degrees is opposite over adjacent. Multiply by X. Now we have X times tangent 42. So to get rid of the tangent 42, we're going to have to undo a times. We're going to divide by tangent 42. And X is going to be 18 divided by tangent 42. You're going to have to type that in your calculator. And if you do it correctly, it is 19.99 feet. But they want it to the nearest foot, so that is approximately 20 feet. They are approximately 20 feet away from the person who needs help. Cool. If we were in class, we would be doing the group worksheet 8.5 at this time. This is going to be optional. You can do this for extra practice. It is in the Chapter 8 folder if you would like to try the group worksheet. This one, the 8.5 homework, is not optional. It is due. So there will be a drop spot for that on Schoology. So please get that done. Thank you. Have a great day.